The purpose of this video is to help us see how to solve a force problem when we have a force that's at an angle. We'll start out, as we do every single one of our force problems, by drawing a free body diagram for our object. In this case, we have a girl pushing a lawnmower, as you can see in our figure here off on the right. Our lawnmower is our object here, so we'll represent that with a dot. We know that every object has a force of gravity acting on it, caused by the Earth. Our lawnmower is also experiencing an upward force, called a normal force, by the ground below. Finally, this person is pushing on this lawnmower with a force that's at an angle that looks like it goes down and to the right. I'll call that the normal force from the person. The problem also specifically says to assume friction is negligible, so our friction force will not appear on our free body diagram. Our next step is to apply Newton's second law, but before we apply Newton's second law, we're going to figure out if our free body diagram is balanced or unbalanced. Based on the fact that the question is asking what's the acceleration of the mower, I know that it's accelerating and not moving at a constant speed. Therefore, my free body diagram is unbalanced. Another way of telling that it's unbalanced is that the normal force from the person, has a component that points to the right. However, there's no force acting to the left that could balance that out. So when I apply Newton's second law here, I'm going to break things up into components. In general, Newton's second law tells me that the net force is equal to an object's mass times its acceleration. And so that means that the sum of all of the x components of the forces will equal the mass times the horizontal acceleration. And the sum of all the y components of the forces will equal the mass times the y component of acceleration. Our next task is always to figure out which component, if not both of them, of acceleration is zero. Thinking about this lawnmower, when you push a lawnmower, as you see in this diagram here, the lawnmower is going to stay on the ground. It's not going to sink down into the ground and not going to rise up above the ground. So it's not going to move vertically. That tells me that my y acceleration is going to be zero, and my x acceleration will be non-zero in this case. I only have one force with an x component, and that's the normal force from the person. So our next step is to figure out the x and y components of my angled force. To do so, we want to draw a diagram of that angled force like you see here, and then draw its components. Specifically, I start at the tail end of that vector, and I see that it goes down and to the right. It's really crucial that your components have arrows on them, just like the overall vector does. Now I notice from my problem that that force has a magnitude of 30 newtons, and it's at an angle of 37 degrees. And you can see where that angle is located based on your diagram on the right over here. I'm going to mark that angle in my picture over here as theta, but we know that that theta is equal to 37 degrees based on the information in the problem. To be able to find those x and y components, this being the x and this being the y, I'm going to use trig functions. Specifically, to find that x component, which is adjacent to my angle, I'm going to focus on the cosine of 37 degrees, and we know that cosine is adjacent over hypotenuse, so it's equal to the x divided by that hypotenuse of 30 newtons. That means that my x component is equal to about 24 newtons. I'll do the same thing with my y component, but this time I'll be using the sine function, since sine function is opposite over hypotenuse. And I get about 18 newtons. Now I'll go back to my Newton's second law expressions. For my x expression here, the only force with an x component is that normal force from the person. I'll just write the word person underneath here. So that normal force from the person, that x component specifically, has to equal the mass times the x component of acceleration. Well, I know what that x component is. That's 24 newtons. And I know the mass of the lawnmower, so I can calculate the acceleration. 24 newtons is equal to that mass, 25 kilograms, times the x component of acceleration. When I do that x component of velocity, that 24 newtons, or really on my calculator, it was more like 23.9591. I divide that by that 25 kilograms. I get about 0.96 meters per second squared. We also need a direction with that. And since she's pushing it to the right, the direction of that acceleration would be to the right. Now, this problem also asks me to find the normal force exerted on the mower by the lawn, or I called it the ground. To be able to find that, we'll focus in on the y component of Newton's second law. So focusing on this equation that I've written up here, I'm going to kind of move down on my page here. I'm going to add together all the y components of force. I have the normal force from the ground. I also have the y component of the normal force from the person. And I have the gravitational force from Earth. All those three forces added together equal 0 because it's not accelerating in the y direction. The normal force from the ground is the thing that we're looking for. That's our unknown in this case. The y component from the person is what we've already calculated to be 18 newtons. But notice how that's pointed downward. So really, I should have a negative sign in front of that 18 newtons for that y component, because in my triangle, my y component points downward. So I'll plug that in as a negative 18 newtons here. And then gravitational force is something that I'll need to calculate. Gravitational force can be calculated using the equation Fg equals m times g. We always want to write out our equation before we use it. Mass is 25 kilograms. And g, anytime it appears in an equation, is always 9.8 meters per second squared. When I multiply 25 times 9.8, I get 245 newtons. That's the magnitude of the gravitational force. However, we see in our diagram that the gravitational force points downward. So we'll plug it in as negative 245 newtons. When I then solve this equation for the normal force from the lawn or the ground, I find that it's equal to 263 newtons upward. It's important, once again, to include a direction with our answers here, since both force and acceleration are vectors. So again, the general process that we went through to solve this problem. We started by drawing a free body diagram and decided that it was unbalanced. Then we applied Newton's second law, looking specifically at the x and the y components. We used a triangle to draw, to kind of find our components of our angled force, and then plugged in values for the forces to find what we were looking for, acceleration and normal force from the lawn.